Good morning, this is Kasturi Day. Today I'll start with heat chapter. It's a physics chapter according to ICSE syllabus class 7. Okay. Now heat. Heat is, what is heat? Things are hot and cold depending on the heat present in them. We know that. Okay. Heat is a form of energy. Then what is it? It is a form of energy. It has the ability to do work. For example, when we put a lid on a pan with boiling water, okay, boiling water on the stove, the lid starts moving up and down. It sounds like duck, 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 duck. You will get a sound of like that. So that represents that the heat which is formed by the boiling water, that is the steam which is formed, it produces heat energy. Okay, and that starts moving the lid up and down. Okay, now the sun is the vast source of heat energy. Main source, you can say, or the vast source is the sun of heat energy. Okay, the heat energy of the sun makes water to become warm and evaporate from the water bodies. Okay, as water vapor the water bodies, from the water bodies, the water evaporates and forms water vapors, and which forms clouds. The water cycle which appears in the nature, we know that after that it again comes back as water in the form of rain. Then the water vapor from the clouds on condensation turns into rain. Then plants uses the heat energy to prepare their food by photosynthesis. So what we can deduce from this, that heat is a form of energy. Okay, heat is a form of energy which flows from a hot body to a cold body when they are kept in contact. Okay, then that is why we feel hot when we touch a cup of steaming tea, or feel cold when we touch an ice cube. Okay, so we can differentiate the temperatures of the body due to this heating effect. Now, what are the units of heat? As heat is a form of energy, its SI unit is joule, and it is represented by capital J. Okay, it is also measured in calories. It is represented by capital C, that is CAL. You can write it like that. Then a calorie is defined as the amount of heat energy required to raise the temperature of 1 gram of water by 1 degree centigrade. So amount of heat energy required by 1 gram of water to raise the temperature by 1 degree centigrade is 1 calorie. Okay, then it has been found that the amount of heat energy required to raise the temperature of 1 gram of water by 1 degree centigrade is equal to 4.186 joules. Therefore, we can deduce that 1 calorie is equal to 4.186 joule. I told you that to raise the temperature by 1 degree centigrade, 1 gram of water requires certain amount of heat, and that is measured. That is equal to 1 calorie, or you can say it is equal to 4.186 joules. Therefore, 1 calorie is equal to 4.186 joules. Okay, or you can say 4.2 joules. Then, as calorie is a small unit, so for practical use, heat is measured in kilocalories. And therefore, 1 kilocalorie is defined as the amount of heat energy required to raise the temperature of 1 kg, 1 kilogram of water by 1 degree centigrade. And we can say that 1 calorie is equal to 1 kilocalorie is equal to 1000 calories. Okay. Then next is sources of heat. I told you the main source of heat is the sun. Okay, I told you the main source of heat is the sun. Then others are electricity, fire. Okay, then the sun is the natural source of heat and on our planet. And electricity gives off heat in many ways. For example, an induction plate produces heat to cook food. A tea or coffee maker provides heat to boil water. A room heater or convector produces heat to warm up the air in the room or so on. We use room heaters in the cold days. Even we use a coffee maker, tea maker, induction oven. So these are producing heat which helps to cook the food or keep the room warm. So these are produced by either fire or by electricity. These machines work due to fire or electricity. Then another simple way to provide heat is producing fire. Then some substances when heated in air catch fire. Okay, and substances which do not catch fire easily. Okay, so these substances which catch fire they can catch fire easily. These are inflammable substances, and those substances which do not catch fire easily, they are non-inflammable substances. Now, inflammable substances combine rapidly with oxygen and release a large amount of heat energy, like dry paper, dry leaves, dry wood, dry cloth, petrol, kerosene, plastic, wax, LPG, and even hydrogen. So these rapidly combines with oxygen and produces a large number of heat. Okay. Next is the non-inflammable substances. These substances, they do not catch fire easily. Okay. Like metals, stones, alloys, bricks, asbestos, even water. Okay. Now, what are the fire safety measures? I told you that some substances, they catch fire easily. Okay, so these to protect these substances from catching fire, there are some fire safety measures are there. Okay, so fire releases a lot of heat, which can be injurious, damaging, and even destructive. Okay, so it should be controlled or dealt carefully. Okay, so therefore there certain precautions or handling precautions and handling measures should be taken to protect this from getting burnt. Then any inflammable substance should not be left close to the fire or electric switches. LPG gas pipes, cylinders or regulators should be checked regularly for any leakage. Okay. Next, what are the effects of heat? Heat cannot be measured directly, but effects of heat can be detected. You can't measure how much heat is there. Okay, but you can measure the effect, how much hot or how much cold it is. Okay. Now, changes in the heat energy. Due to the heat energy, there are some changes which takes place, like change in temperature, change in size, and change of state. Okay, so change in size can also be named as thermal expansion. Due to the heat, there is expansion in the size. Now, first is change in temperature. When heat is supplied, there is rise in temperature of the object. Okay, when heat is supplied, there is rise of temperature in the object, and when cooled, the temperature decreases. Therefore, the amount of heat gained or lost by an object can usually be found by measuring the change in temperature of the object. So, how much heat has an object gained or lost? This can be measured by measuring the change in temperature of the object. So, what is temperature? Temperature means the measure of the degree of hotness or coldness of a body. Okay, the measure of the degree of hotness or degree of coldness of a body. That is measured in degree centigrade or degree Fahrenheit. Or SI unit is Kelvin. That is it is not written in degree K, but it is written as capital K only. Otherwise, or you can write in centigrade or Fahrenheit, but that is written in degree C or degree F. Okay, the device for measuring this temperature is thermometer. Most common thermometer is mercuric thermometer. Now, how to measure a temperature? By mercury thermometer. The mercury thermometer consists of a glass capillary tube with a bulb at one end, and the bulb is filled with mercury. Okay, the long part of the capillary tube is known as the stem. Now, the stem has markings from minus 10 degree to 110 degrees centigrade. That is with 120 equal divisions in between. Okay, minus 10 to 110 plus 110, that is. Okay, then see, this is the thermometer. This is the thermometer. This is the long stem. The markings are minus 10 to positive 110. And there are 120 divisions, equal divisions inside this. And this is the bulb which has the mercury in it. This is the capillary tube. Okay. Now its 0 mark, that is the ice point or the lower fixed point, or that is the point of melting ice. And the 100 mark, this 100 mark is the stem point or steam point or upper fixed point or the point of boiling water. Okay. Now, to measure the temperature by a thermometer, how can you measure it? The bulb of the thermometer is kept in contact with the body of whose temperature is to be measured. Now, what happens when the mercury bulb comes in contact with the object which has to be measured, which has a temperature? The mercury, due to the temperature, it gains the heat, and what happens? The mercury expands and rises in the capillary tube. Then wait for some time. We need to wait for some time till the mercury stabilizes to a certain point. The rise of the mercury stabilizes to a certain point. When the mercury does not rise further or get stabilized at a level, then the reading of the mercury of the markup to which it has been the mercury has risen is noted. Keeping an eye in a horizontal line, you have to keep the eye on the reading on the line where the mercury has stabilized by keeping it in horizontal line, not sideways. Otherwise, you will not get the correct reading. Then that will be the temperature of the body. Now, temperature scales are 3. I told you they are Celsius, Fahrenheit or Kelvin. Celsius, the lower fixed point is 0 degrees centigrade and upper fixed point is 100 degrees centigrade, and divisions are 100. Fahrenheit, 32 degree Fahrenheit is the lower fixed point, and upper fixed point is 212 degrees Fahrenheit is the upper fixed point, and division is 180 divisions are there. In Kelvin, lower fixed point is 273 Kelvin and upper fixed point is 373 Kelvin, and the divisions are 100. Okay. Now, the relation between the 3 scales, okay, of the thermometer, between Celsius and the Kelvin. 0 degrees centigrade, that is ice point, is equal to 273 Kelvin, and steam point 100 degrees centigrade is equal to 373 Kelvin. That is, therefore, T degrees centigrade, that is the temperature which we have to know, is T degrees centigrade is equal to 273 plus T. T means the centigrade temperature. So, adding 273 to the temperature of the Celsius scale will give you the temperature of the Kelvin scale. Okay. Now, between the Celsius and the Fahrenheit scale, ice point is 0 degree Celsius and Fahrenheit is 32 degree Fahrenheit, and steam point 100 degree centigrade, that is Celsius scale, and that will be equal to 212 degrees Fahrenheit. Okay. Now 1 degree, therefore 1 degree centigrade on Celsius will be 9/5 on the Fahrenheit scale. Or you can say F is equal to Fahrenheit temperature is equal to 9/5 C plus 32. Or C is equal to 5/9 F minus 32, or you can say C/5 is equal to F minus 32/9. Okay. So the change in temperature of a body depends on the quality of the heat imparted to or rejected from the body, the material of the body and mass of the body. Okay. So I stop here. I'll continue with this chapter in the next video. Please go through this. If you have doubt, please let me know. Okay, thank you.